like I said, dinner was good, and I'm back. Scene. Okay. Step 7. Write a DHCP and DNS server in the host for a virtual guest. Firstly, let's just make a OCI folder, and on OCI. This code is a bit messy sitting here, so let's just move all of that over to here. Make OCI image downloader public and add a new downloader OCI image downloader. Protect that. Then make that public as well. And then instead of this, the old thing, we do OCI new downloader, and then OCI dot. Cool. Let's just check to make sure this still works. It does. Okay. Just connect this quickly. That. This whole file is screaming, clean me up, but soon, eventually. Right, a DHCP and DNS server in the host for the virtual guest. We don't really need a DHCP server right now, but it'll be a cool thing to have. But let's start with a DNS server. Type DNS server struct. DNS server is a network thing, so we'll do it here. To fix this horrible hack. Also a later problem. I will also wrap that in a separate go routine, and then DNS server, and then honestly I don't pay much attention to the DNS server. I got it working forever ago, and then it's just been a thing ever since. I will need a listen packet internal function for it, but besides that, the DNS library that I'm using is, because we're not going to write a DNS server completely from scratch, we're going to use an existing one. So this will have server star DNS server, there we go, and then this will pretty much just do DNS.server equals go mod tidy. UDEP. 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 There we go. Server is a .dns.server. And what is the default DNS port number? Port 53. We're using UDP. DNS packet con equals net dot packet con. NS dot listen listen and where's the mux? DNS mux. Yes, DNS also has a DNS also has a similar thing, and we'll just listen on packet 53. And swap. And the DNS server function will have a handle DNS request. And then that will in turn have a pass query function. The DNS and DHCP and DNS servers are nice and simple. I didn't expect to rewrite or make any major changes to them compared to how my previous code works. In fact, I'm just going to design it right now. I'm just going to drop the fact that we're going to do a DHCP server. Since it's not strictly needed, the VM already has an IP address. It just needs DNS. Okay. We basically just do call s.dns lookup with the IP address, which is q.na, and then notice that we do not currently support multiple questions in one DNS request. We just silently drop them. Probably shouldn't be doing. slog.debug. Name thing, and then error is error. R code server failure. I believe this is the correct one. Not actually sure. But yes, that looks a bit better. So now this means we can do multiple DNS lookups. This has to be the DNS mux. It's not the HTTPS mux. So DNS server has a function for that. This is an IP, this is name. Can do reverse DNS lookups, and we do not implement that yet. If name is equal to host.internal, return 10.42.0.1 nil. Else return empty nil. There we go. DNS. We just need a listen packet internal function. DNS star. Let's stack. Listen packet internal. Net dot packet con, I believe. Yep. Now, as user. This code is a bit more complicated because it tries to handle some weird edge cases around things like broadcast addresses. And now we will just need to write etc resolve.conf. Write etc resolve.conf. Short etc. Alright. Name server on. This just tells it what the DHCP server is. We probably don't need that anymore. Set the hostname. And then we just need to implement path.ensure and file write. And this should work, hopefully. Here's a little file.write method that I prepared earlier. And here's a little path.ensure method I also prepared earlier. Thing login.internal. Okay, can't find that, but if I ping host.internal, yay, I get a response. But if I Control-C, then Qm just terminates, which is annoying. Let's fix that. That is next problem on chopping list. But just done step 7. Nice and simple. Only took 15 minutes. there's step 7 committed. And now on to step 8. Switch from using stood out from queue to SSH from the host. And yeah. Okay, switch from using stood out from queue to SSH from the host. This requires a few different bits of code to work. Firstly, it requires a in the netstack code, it requires a dial internal. Nothing surprising there. Dial internal just allows us to make some kind of network connection from the host into the guest. Well, from the host into the network that the guest is on. And since we already know the guest's IP address, this just allows us to establish a connection with the guest. So now we will add a magic little function that just says run SSH server, giving them a bit of control over that. So we have a globals run SSH server. It's just a Starlock built in. And this will just return none run SSH server. And we'll have a func run SSH server, which can return an error, which just runs an SSH server. So SSH, that code's in here. Where did I implement that? Okay, I implemented it here. Listener errors net.listen. Config is ssh.serverconfig. Password is insecure password. And generate the private key. And then for ncon is listener.accept. Then we handle the SSH client. Type SSH server struct. Funk. And then we just have a funk. Some brief things about how the SSH protocol works. So, SSH has a very convenient multiplexing facility that it runs over the top of connections. So one single SSH connection with its cryptography over the top of that can actually have a variety of different channels running inside of it. And those channels running inside of it can be things like shells, but they can also be forwarded ports. They can also be things like SFTP and all that. Whenever you're connecting to a server over SSH, you're creating an SSH channel for the session. You're doing things like requesting a PTY, which is a pseudo terminal, and then the server is giving you a shell on the system. All of the authentication and authorization happens before we reach this stage. So I'm going to do some refactoring and cleanup. I'm going to do some refactoring and cleanup of this code a little once the basics of this are copy pasted. So we will actually just allow the client, when it goes into this, to also pass a, so this is password command string this command equals command, and then all the way down here is and the command is login-f root, and the password is insecure password. Very insecure. Okay, so handling that can throw an error. If error is not equal to nil, then slog.warn fail to handle SSH client error. Just like that. This is an SSH server class, so it looks like we just need to fix some of these errors first. Let's not handle resizes just yet, and handle resizes a little later. Okay, this common.proxy function we'll need a copy of. let's just put this in a separate file. Proxy.go. Package name. Proxies like that. All proxy does is it says every time there's a read that comes into one connection, write it out the other match reads with writes and writes with reads between two connections. It proxies between the two. We do not want this zero log stuff, so we're going to say slog.1, and we would, yep, I'm going to say slog.1. TinyRange has a separate log module which works essentially exactly the same as slog, although it predates slog. So in this case, it's easier just to use slog all the way through. So new SSH connection, handle a client. This means still errors. Go. Sure, that's fine. There's still some bugs in this SSH code which I would like to fix ideally. This SSH code, I believe, comes from fly.io's SSH code. Connections not used. Not surprised. That's now called handle client. It's now called handle channels. It's now called handle requests. It's now called handle channel. That's now called chat shell. Yeah. So okay, this will now, when the virtual machine starts up, it'll do the Docker pull, and then we will get a whole lot of nothing, and then I'll just say it's configured networking statically. So what we would like to do on the host side of things is to actually connect to this over SSH. So I will also do a separate go. Error is connect over SSH. Host address is 10.42. Address is whatever one we statically defined it here. 10.40.0.2, colon 2222. Username is root, and password is insecure password. And then error is not equal to nil. Slog.error failed to connect over SSH. Error. And since SSH is going to be the main body of the work that happens here, we will actually make it so that the virtual machine's run is put there. So slog.error failed to run virtual machine. This just means when we exit out of the SSH session, it will immediately shut the virtual machine down. So error equals connect over SSH. And then we will have a trunk connect with our SSH. Address, string, username, string, password, string. You'd imagine, of course, that because we can communicate with the host as soon as the HTTP server is up, we could separately send the password that we want to connect back to the host in a request that the guest gets from the host. So we could have a provision the guest with information that has the guest download all the information that it needs to run. We could do that as an alternative, of course, but in this instance, that doesn't get you the same security guarantees necessarily. Since the host controls how the virtual machine boots up in the first place, and the network stack is entirely virtual, you'd have to somehow send packets to the guest from an address that it wasn't expecting them from, for the guest to be able to, and then the guest to be able to receive those packets and then believe that it's an SSH connection coming into them. That sounds like an interesting attack and may well be theoretically possible, but it's not something that I really consider in practice. The only other reason to set a more secure password than the one that we're currently using is simply because clients inside the guest can SSH into it. The guest can SSH into itself, which actually, in the scheme of things, is a useful way of testing this. So why not do that? Because we can just install an SSH client in the guest and try SSHing into localhost and see what happens. Nothing's stopping us from doing that. Except for the fact that this run SSH server is a blocking thing. It doesn't have to be. Run login -f. Let's just comment all that out, and when we go here, okay, why didn't that work? Oh, because we don't have a path variable, so we need to specify that explicitly. Right, we do not have the ability to do APK add, so we would need to embed the SSH client into that. That's annoying. We don't get to do this the easy way. Of course I could just build a Docker image with that, but that sounds like more trouble. So just run SSH server and make it so that running the SSH server is persistent. Yes, it is. And then we just need to implement our connect over SSH function. These are not difficult. So connect over SSH. How do you work? Just do config. And I actually use... let's just try dial internal. Let's say that requires a net stack. On error. S.dial internal. TCP address. Error is nil. Error. And then this is the SSH client, which does that. And then we use the client to create a session. And then we, importantly, try and make and then importantly we make this raw. Well, okay, so we make the FD that we make standard in raw, which is not what's happening before. This means that it should interrupt Control-C. Because right now, things are just piping through directly and Control-C is not getting interrupted properly. This will properly interrupt Control-C. And so we are going to do FD OK. We will always set term is equal to Linux. This means we won't get color, but I don't mind. And I is 40. Normally we would get the width and height properly, but in this case we're not going to. And then return nil. Stood out session stood in equals os stood in, and session stood error equals os stood error. Cool. Right. Oh, got all tidy. Net stack. Yes, this should theoretically work. Failed to connect, no root toast. Is the amount of time that we're waiting not enough, perhaps? Maybe? Okay. That's actually an error over. That's actually an error over here. Although you can see that we do actually need to defer virtual machine dot shutdown. Defer virtual machine dot shut down. VM star virtual machine shut down. That's an error. If VM.cd is to nil, VM dot cd dot kill. I'll just check to see if I have another QM instance running. There we go. Make sure to reset the terminal as well. And now VM.cd is that. Those go there, and that goes there. Failed to start shell EOF. That normally tends to happen if just do a find output all if find output and find output all. If QM and the SSH code are competing with each other for access to the standard output things, then that causes a problem. So we'll just pass false into here. This means the VM will start up, but then it'll go fail to start shell EOF. Fail to start shell. Did we actually fix that? Then let's just allow this command to be sent by the host instead. See how difficult that'll be. just do session.shell. Instead of looking, yeah, let's just do looking F. Okay. Having a little bit of extra stuff on there makes me think that I should time.sleep 100 times time.more. Makes me think I should have this wait a little bit. Could not start PTY exec bin login F. Right. So let's see. Can we do this bin login stuff normally? Connection was refused, connection was refused, connection was refused. Okay. That means we can run bin login normally, but we cannot run it in this context when we do the exec.cmd. I believe the exec.cmd uses a special pty thing to do. Yeah, it does pty.start. Could not start. So that means the error would be could not start pty. Which is trying to do start with size and start with attributes. Which means it's trying to open dev ptmx. Right. Does dev ptmx exist? That's a good question. Because if it doesn't, then that probably is what's causing this. Need to go. Main. Like I said, you have to make sure that you have all those things mounted correctly, otherwise your Linux system gets a bit grumpy with you. So I will virtual machine run. Dev ptmx. Okay, it exists. It's writable. SSH, can't access TTY, job control turned off. What mounts do I have? That's set of mounts. And now if I do a regular TinyRange login, which this is doing that in the background, let's see what mounts I have on you. They should be exactly the same. Rock, devtempfs, sysfs, cgroup2, bpf. They are exactly the same. So why is the So we... So we don't necessarily have to start the PTY, but let's just do it. See what happens. Right. Fork exec bin login -f root. No such file or directory. Okay. That's suspiciously simple. Could not start PTY fork exec. So in turn, what causes this? PTY start will start with size, which in turn will start with attributes. And then open returns open. All of these know the command that's being run. So this is doing the actual starting of the command. Oh. Exec.command takes arguments in a separate thing. Ah. Hold on. Ah. No. 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 If this is it, then I'm not happy. Maybe it's not. Although, in this case, I think it is. Like I said, the two conflict with each other. So if we set this to false now. Then voila. We get a VM. We can do Control-C in the VM. That works. And then when we exit out, we drop back to a terminal. Congratulations, we have successfully switched. We have successfully switched from using stood out from Qum to SSH from the host. We've still got an insecure password. Code is still a little messy. I'll try to refactor this stuff now. So I'll just add dns.go. And I'll just add ssh.go. Just trying to split these into separate files so it's a little neater. Right. This is not ideally perfect because it doesn't actually handle terminal resizing gracefully. But it works. It's an SSH session. It now means that if I press Control-C, things work. Also, it means we get the output silenced nicely. Starts up, get an SSH session into it. You can just run this with this command directly, and it works. I'll just say on the getting started quickly that that part of the command is no longer necessary. And yeah. Get comment-m. Part 8. Switch from using stood out from Qum to SSH from the host. Step 9 is add support for connecting to arbitrary websites in the guest. I'm thinking whether I'd like to get that done tonight or whether I would like to defer that to some later date. Simply because if I was to defer it to later probably means Monday. And the reason for that is this code tends to be very finicky. Mostly because it relies on doing a bunch of I can explain this part briefly. Add support for connecting to arbitrary websites in the guest. Okay. These words mean something. Notably, note this part. I didn't say connect the guest to the host network. That's not what I said. I also didn't say add support for connecting to arbitrary support for connecting up for arbitrary network connections in the guest. See how my spelling is horrible. Okay, so I said this first one with emphasis on websites. I didn't say the second one. I didn't say the third one. Why? The reason for that is quite simple. Well, the reason for that is a little involved. Connect the guest to the host network. That is something people do with Qum quite often. Although the way that you do it, this is OS specific and needs root privileges. Regular applications on your computer cannot send arbitrary network packets, which is what's required for this first step to work. Because it essentially requires a layer 2 tunnel to the host channel. That requires root privileges. Add support for arbitrary network connections in the guest. This is where I'd like to get to in the future, but it involves some extra steps. Because this happens at an IP layer, aka layer 3. Look at connections coming from the guest and maintain separate connections on the host. This is doable. It's complicated. This is, I believe, what Slurp is called. Yeah, it's Slurp type things. And finally, add support for connecting to arbitrary websites in the guest. Happens way higher up the stack, layer 5, I think. Yeah, layer 4 or 5. Happens higher up the stack inside the HTTP server. Can intercept SSL. That's something that we're going to be implementing. SSL interception, so we can see all the requests that the guest is doing. We have full access to them. Very exciting. And then, yeah. And notably with this, enough for most applications. enough for most applications and package updates. Basically anything that uses HTTP or HTTPS. Would like to get to this one eventually, and I would like to explore code, although that's further down the list. Other TinyRange does not support that yet. And finally, add support for connecting arbitrary websites in the guest. That's not supported yet. But this kind of part is generally necessary because the thing is, if we start up this virtual machine right now, and we try to do apk add gcc, it's like, oh no, we don't know where dlcdn.alpinelinux.org is. We just don't. And in fact, it's trying to request these over HTTPS, not HTTP. So our server, which is listing on HTTP, won't work. Also, even if we were running on HTTPS, we need a little bit of additional logic to handle the HTTPS certificate from the host. But that's nothing a little int.star magic can't solve. But yes, this will be a bit more involved. It's 9:30 my time, and I've work tomorrow, so this is a bit more involved than I'm wanting to get into tonight. So I will defer this to some other night. Maybe Monday, maybe Tuesday. We'll see. But anyway, thanks for watching. Bye.